In the previous lecture, we understood about exception entry and exit sequences. Let's do an exercise to see practically how processor handles exception entry and exit. Here I have created a project exception entry underscore exit. Here is the main.c, and I'll just pull the code from my earlier project operation modes. So I'll just copy this code here. This is a thread mode code, isn't it? All these are thread mode code. Here is a place where we generate the interrupt. Let's get into that function. I'm going to keep a breakpoint here in the generate interrupt. Let's run. This is a instruction which triggers the interrupt. When the interrupt triggers, what happens according to our discussion? That is exception entry or interrupt entry. Stacking takes place. MSP will be decremented because our stack is full descending, and a stack frame will be pushed to the stack automatically by the hardware. Let's check this. Here now the interrupt is not triggered. The code is still in thread mode. This is the instruction which is going to trigger the exception. First note the MSP value. Let's go to the register and let's get the MSP value or SP value, because in our case SP is nothing but MSP. This is SP. Let's note this somewhere. This is a stack pointer pointing to the last stacked item. That means the MSP is now here, last stacked item. Whenever interrupt triggers, MSP will be first decremented and a stack frame will be pushed. That means the first content or first register that will get pushed to the stack is nothing but XPSR. Let's verify that. So the address of the stack frame starts from FE4, because this will be first decremented and XPSR will be pushed first. What's the value of XPSR? This one. Let's copy that too. If we observe this memory location, we should find this value. Let's check that. I'm going to hit run here. Here you can see that interrupt is triggered and processor is executing the first instruction of the ISR. Now let's observe the stack. Let's go to the memory browser. Observe this memory location. Yes, you can see that this is the value of the XPSR. What is next? Next is PC, and after that LR. Let's verify that. Next one is PC, LR. The memory location address would be decremented by 4. That means 0. This will be decremented by 4. That would be DC, like that. What's the value of PC? Go to the memory location and let's decrement this by 4. You can do -4. You can see that this is a return address. To this address, processor should go back when it finishes the ISR. So like that, all these register contents are saved onto the stack which is pointed by the MSP. This is what we call as a state of the thread mode code, or we can call it as a stack frame of the thread mode code, and this state has to be retrieved back whenever processor exits the ISR, that is the handler mode code. In the ISR, this is ISR, this is a disassembly of the ISR, and you can see that this is the first instruction of the ISR. Let's keep a breakpoint there, reset this board, and let me hit run. Now the processor is executing the ISR, and this is the first instruction of the ISR. At this stage, check the status of the LR register. Just open my registers window. Just check the value of LR. Here it is. The LR is loaded with a strange value. This value we call it as exec return. Let's note this value. When the processor made an entry into the ISR, the LR is loaded with this value 0 cross FF, 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 F9. And as we discussed in the previous lecture, when exec return is written to PC, it triggers the exception return. That means the processor leaves this ISR by writing that exec return into the PC. You can see that in the disassembly. This is a disassembly of the IRQ handler, and where is the return? So you can do one thing, you can keep a breakpoint here at the end and you can hit run. This is a place where exception return takes place. You can see that this is a pop instruction. That means pop two values from the stack and populate into these registers. That means PC is getting modified here. What is the current value of stack pointer? Let's see that. That is this one. Copy that and let's go to the memory browser. Yes, here you can see that this value is copied into R7 and this is the exec return value, and this value will be popped into PC and that triggers the exception return. As per our discussion, these are the possible values of the exec return. The processor using this value. The processor has generated this value at the beginning of the ISR and it is now using this value at the end of the ISR. What this value signifies? Return to thread mode. That's correct. Processor decodes this value at the time of ISR exit and it understands what to do next. This value signifies that return to thread mode. That's correct. The code should go back to the thread mode. While going back, the state, the already saved state of the thread mode has to be retrieved back using MSP as the stack pointer. Exception return gets state from the main stack. And once the thread mode code resumes execution, the execution uses MSP as its stack pointer. That's correct. We never used PSP. Thread mode always started with MSPs. So that's why after return, it should also continue using MSP as its stack pointer. All these things processor will understand by decoding this exec return value. Let's trigger the exception exit. Just activate this instruction debugging and let me just hit single step. Here you can see that the PC is about to get modified. The execution control goes back to thread mode code at what position? The execution control goes back to the thread mode and resumes at return address. This is a return address of the thread mode code. This is the address. This whole stack frame will be retrieved back and this value will get loaded into the PC. If you check that address, you just paste here and you can see that the execution will resume here in the thread mode, which is part of generate interrupt. Let me just hit step into and you can see that we resumed in the thread mode code. Now I just did a small modification to this code. I changed the thread mode stack pointer to PSP. Here you can see that I first initialized the value of PSP register using this inline assembly code. After that, I used the control register to change thread mode's stack pointer as PSP. Again, test this code. I'm going to keep a breakpoint in the ISR. Go to the disassembly and paste that name here. This is a ISR, and let's keep a breakpoint here. Let's hit run. We are in ISR, and now check the value of the exec return. Go to registers and let's check the value of exec return. Here it is. This time it is showing FD instead of F9. Let's decode FD. Return to thread mode. That's correct. Exception returns get state from the process tag. That's the meaning of FD. And execution uses PSP after return. So that's about exception entry and exit sequences. Do let me know if you have any questions, and I'll see you in the next lecture.